Hello everyone, welcome to this session. Our chapter is map work, and as in our previous video, we discussed how you can measure the straight distances and the curved distances. We saw various methods on how you can do that. So today let's move on to the other part where we'll see measuring of the areas of regular and irregular figures on the map. So we'll be discussing areas of the regular and irregular figures on the map. So briefly, we know that irregular figures, you can just measure the areas in the map simply by applying the various common uh, uh, their formulas. For example, if you see a figure in the map that is in a form of a cycle or a rectangle, you just apply the formulas for finding those areas of such specific figures. So we'll dive into more on discussing areas of these irregular figures and how you can measure their distances on the map. So let's dive into it. Areas of regular and irregular figures. So the figures whose areas are calculated in maps, they can either be regular or irregular shapes or figures. So we'll dive into more calculating areas of the irregular shapes. So figures with the regular shapes on the map, we know, for example, rectangular, triangular, square, or circular. Finding these the areas of such figures is very simple. Simply you apply the mathematical formulas. So mathematical formulas are the ones that are used to calculate their areas. However, it is not common to find such irregular features on the map. So we regularly find the irregular features or irregular shapes of these features on the map. Now calculating areas, just simply, this is a brief calculating areas of different irregular shapes. Triangle, you know that you can get the multiplying the length times width, will get the area. Square, the same length times 2, whereby L that stands for length of the side of the square. So square, obtaining it, just L times 2. Triangle, here we'll have to have a half BH. So B is just the length of the base, and H, that is just the length of the base, and H is just the length of the height. So you just obtain the area of the triangle. Cycle, pi r square, or just pi d square over 4, where r is just the radius, d the diameter, and pi is 3.14 or 22 over 7. So that's simply how we can calculate areas of different irregular shapes. Now, when calculating areas of irregular shapes, features with the irregular shapes are very common on the maps. You'll find such figures in these kinds of shapes, such as features like lakes, forests, plantations, settlements, marshy land, etc. So, an example of irregular shape is illustrated here. So, this you can see in the map. Now, how can you find the area of this given feature on the map? So we'll dive into it. So methods used to calculate areas of irregular shapes. Now there are three methods now you can calculate areas of irregular shapes. These are as follows. The first one is division method, the second one is tracing method, and the third one is grid square method. So all these three are there just to help you to calculate the areas of irregular shapes or just irregular features on your map. Now we'll start with the first one, division method. In this method, the area to be measured is divided into rectangulars or squares and triangles, or into several strips of the same length and width. Now then the area of each resulting figure is calculated using mathematical formula and summed up to get the total area. So that's simply way on how you can find the area of these irregular shapes by using the division method. So here the procedure is simply divide the whole area into these various figures, which are regular figures. You're talking about the rectangles, the squares or triangles. Then calculate the area of the rectangles, squares, and triangles using the mathematical formulas which they are given. Then sum up individual areas to get the total area. Now remember that the area should be in the same units at the map scale. So that's simply how you can calculate that. So here's an example. We have this irregular shape, but it has been divided into regular shapes within it. So we've divided into three figures or these three shapes which are just regular, we've divided this irregular shape into a rectangle, a triangle, these two triangles, and a rectangle. So from there, just the area above we've seen here is divided into three figures, A, B, and C. The area of the three figures, resulting figures, is calculated as follows. We know the rectangle, get the area length times width. So in terms, maybe there are units there, so 10 times 5 equals to 50 kilometers square. Triangle B, half times base times height, so half times 6 times 4 equals to 12 kilometers square. Triangle, given triangle C, area we know is a half times base times height, so it's equal to half times 4 times 3, that is equal to 6 kilometers square. So the total area will be equal to A plus B plus C, so 50 plus 12 plus 6, you get 68 kilometers square. So that will be the area of this given irregular shape, the outside one. Moving on, so the other method division of the area into strips. So this is the other method. Now you can calculate the area of these irregular shapes. So the stripping method, it involves dividing the area into strips and then calculating the area of each strip separately. So this is the stripping method, division of area into various strips. Now the total area is obtained simply by summing up the areas of the rectangular strip. So in stripping, you divide basically based on these rectangles. So in this irregular shape, we've divided into 5 strips. And moving on, here are the procedures for method of this dividing, of finding the area of this irregular shape using the stripping. So procedures, there's first, the first one, divide the area into uniform rectangular strips, then calculate the area of each rectangular strip separately. Remember that the areas of the strips should be in the same units at the scale of the map, then add up the area of each strip to get the total area. Now, so area simply will be equal to sum of the areas of all individual strips, so the area of 1, 2, 3, 4, 5 according to the figure above. Now you get the total area of the given irregular shape. Now let's move on to the other method, that is tracing method. Here the procedures on how you can carry out this tracing method. The first one, trace of the outline, that is the boundary of the figure to be measured, onto a tracing paper, or simply graph paper or ordinary tracing paper, and transfer the outline into a squared paper. Tick and count all complete squares and sum up their areas. Remember that each full square measures 1 centimeter times 1 centimeter. Mark all incomplete squares with crosses, then count all incomplete squares and divide the sum by 2 to get the number of complete squares. Then add up the squares in 3 and 4 just to get the total number of squares covering the area of the figure to be estimated. Then using the scale provided, simply find the area of one square in order to obtain the actual area that would be covered on the ground. Now just note that the area that you calculate is the approximate area. And so here's the example. We have this kind of a irregular shape here. So what we've done, just we've divided into these a couple of these shapes by using maybe a ruler. You can use a ruler just to get the correct measurements, or just transfer this irregular shape into a certain kind of a graph. Then from there you mark the full squares, just as the procedures how they said. You mark up the full squares that have not been crossed, and you also mark up the remaining half squares. So the half squares are the ones that are not fully marked. As from here you can see the ones that have the tick sign, it means that they are full squares. Now from there, according to the figure above, as we have seen, the number of complete squares, if you count them, there is 28. Now the number of incomplete squares is 25. Now to get the complete squares, we simply we divide 25 by 2, so we get 12.5. Hence the total number of complete squares in that kind of irregular shape is 28 plus 12.5, we get 40.5. Now this is the same as 40.5 centimeter square according to the size of each square when we are transferred into according to the size of each square when it was transferred into what, into the graph. So assume that the scale of the map may be but when you are calculating, yes, you get the common scale that is on the map. Here we assume that the scale of the map is 1 to 50,000. Then the area of 1 centimeter by 1 centimeter on the ground is 0.5 times 0.5 kilometer, that is 0.25 kilometer square. Therefore, the total actual ground area of irregular shape is calculated. Thus, area is equal to 40 times 5. 40.5 times 0.25 equals to 10.125 kilometer square. Now, you should remember that if you don't have the tracing paper, you can draw the squares straight on the map using the following procedure. Now, using the tracing paper, if you don't have it, now here are the procedures on how you can do it on your given map. Simply mark by a pencil the margin of the area to be measured, then using the grid reference lines as your guidelines. So use your grid reference lines as your guidelines, then draw the squares with faint pencil lines across the area. Now, if there are no grid lines, make sure you draw light angled squares across the figure. Now mark your full squares and half squares and follow the above tracing method procedures just for calculating the area. So that's how you can do the tracing method. Now here is how it is on the map. So this is what has been carried out according to the procedures that have been explained in the previous slide. Now the scale given here is 1 centimeter is equal to 1 kilometer. Number of full squares 100. Now total number of half squares 48. So the total area will be equal to 124 square kilometer. Now let's move on to the other method, the grid square method. If the map provides grid lines, so the grid square method can be used to calculate the area on the map. The grid squares formed by the lines are used in this case. For example, in topographical map of scale 1 to 50,000, the distance between successive grid is 2 centimeter. So this length is equivalent to 1 kilometer on the ground. Therefore, every grid square every grid square on this scale map just represents 1 kilometer square on the ground. Now consider the diagram below. So this is the diagram, and we've marked the full square and the half square. So the number of full grid squares is 18 and the number of half grid squares is 19. So the total area will just be equal to 27.5 square kilometer. So that's all I have for this session. We've seen on how you can calculate the areas of irregular shapes, but we've seen briefly on how you can also obtain the area of these irregular shapes. The ways of calculating the irregular shapes, we've seen briefly on how we can calculate them. We can calculate them: the triangle, the rectangle, the circle. So yes, you apply the mathematical formulas. But in terms of the irregular shapes, we've seen the various methods on how you can use just to calculate their areas. So that's all I have for this session. I hope that's clear, and thank you.